another stream of NES Programming. This is stream number 21, and I'm not exactly sure what we're going to be doing today. There was one optimization I wanted to make. I expect that this is going to be short or shorter than usual just because I am getting back into the swing of this after being off for a week, but I was thinking about some of how we did the tile loading code here and realized that one thing that we could make a little bit simpler was my code for essentially the modulo that we were doing. So the idea was that in these sections here with the meta tiles, I wanted to be able to loop through the meta tiles, which are 4x4, and in a screen made up of meta tiles. Iterate through those, and I was using them a really sort of rudimentary routine or set of code to do that, where it was just counting up to 4 and then resetting it back to 0 in a separate counter called mTileX, mTileY for metatile X and metatile Y. And that was separate from the actual metatile counter itself. And I realized that we could make this a little bit more efficient by, instead of counting metatile X or mtile X and then doing a comparison in a branch, we can actually be a little bit smarter about this and use the fact that we're checking for a power of 2 to simplify this. So instead of this stuff here where we're saying, okay, increment mtile X and load it, this part is fine, but instead of doing this where we're resetting it, all we need to do is AND it with the value 3. And for why that works, it's actually pretty straightforward. If you have a binary number, like we do, and you're counting up, and you want a number 0 through 3, like we do, right? Because we never want to actually get to 4, we just want to get through these numbers all the way up to 3, then essentially what we're saying is we don't actually care about this at all. So when we do the increment of this value, if we get this set to 1, what we want is the value 0. So by doing an AND, a logical AND, or bitwise AND I should say, on this, we're effectively discarding these bits, which is good because then we get the value 1, 2, I have one extra bit in here. You get the value 0, the value 1, the value 2, right? And the value 3. And then you carry the bit over into here, which gets discarded, and you go back to 0. So that's a much easier way of doing this. And again, because it's a power of 2, if it were some other number, this approach would not work nearly as well, or at all, I don't think. So we do the bitwise and we just store the value. And then we can do the same thing here where we increment mtile Y, we load it into A, we do our bitwise and then we store it. So we save doing a comparison and a branch and a separate store for if it's 0. We're storing every time now, but all in all, this is going to be a little bit more efficient. So let's see. I think that's going to be okay. And this should work. Now, if you remember from last time, what we had done is we had this map of meta tiles, right? So this is one full screen. This is another full screen. So the meta tile 2, go back to our asset tool, launch that. We had this gradient meta tile, right? So that became meta tile 2, and then we had a solid blue meta tile, which is just that one. And based on the way they got loaded, we have our blue tile is 1 and our gradient is 2. Now obviously we wouldn't want to hard code this in like we're doing here with the meta tiles, but I'm just doing that for the sake of testing out our code to load the the screen up. And then I also have to define what these meta tiles are. And again, the asset tool should be writing this out, and we'll get to that in a second. So meta tile 0 has nothing. What does it have in it? I guess it has nothing. Oh, right. It has nothing in it because that's, you know, that means there's no background there. It would just be whatever the background color is. So let's see how that panned out with that change to use the bitwise and instead of the compare and branch. And that looks good. And so we should see it alternate between, yeah, cool. So that actually worked the way that I expected to. And I'd been sitting on that since before last week. And it's like I kind of tweeted about when after the stream, or I guess it was the next day, I was sitting and thinking about something else, and then suddenly realized that this was a much better way of handling it rather than doing the check and compare. Makes me wonder if we're doing anything else like that elsewhere, where we're, you know, essentially doing a load A of 0 and then storing it based on a value that's a power of 2. Because now what we can do is anytime we get that, we can apply that logic to do the modulo, you know, more efficiently than we were doing it before. I don't necessarily want to go searching for all of those places. Like in this place, we have 3C. I don't remember what this was. This was some counter. One thing that I did notice when we started in here, or when I started getting ready for the stream, was I noticed that the game is loading the map and then kind of just sitting there. And so I'm wondering why that is. It's going to be a little bit interesting to see what the heck is going on there, because it should just be loading the map and then moving on. So I'm actually curious also to know how many cycles this took. So what we can do is we can, well, let's take a look at first why it is sitting and doing nothing, like what it's doing during that time period that it looks like it's doing nothing. I'm sure it's looping on something, but the question is what. So debugger. We start, and then I'm going to run line. All right, so where are we at? So load A4, compare 1. Oops, I didn't mean to do that. Damn it. Let's reset. Run line. Okay, so we're here. This is, what is this? Push A, load A to transfer X to A, push A, transfer Y to A, push A, load A. Is this the interrupt? Finished. It is. Okay, so we step out of that. We are No, step out. Step out is currently in process. Cancel it and set up a new. No. Step over. So, guess I'm looking for the return from interrupt. I'll just set a breakpoint here for now. Run. Delete. Step over. Alright, so what is it actually doing right now that it's sitting here doing nothing effectively? What is this code? SBCEC. I don't see that. Is that... No. Process player. Could that be it? Yeah, that looks like that's what that is. Alright, so we are in the gameplay state. Why does it look like it's not doing anything in the NMI? I keep clicking all the wrong stuff here. You just set a breakpoint here. Well, you just set the breakpoint a little bit higher. We can set it towards the top. This is the velocity calculation we're in. So here are the controls. Let's look for our control stuff. Oh, well, that's actually going to be higher up, I guess, right? Downloading tiles, jump game loop, playing game, load a controller, and 1-0. Okay, this looks like this is... Yeah, so this is the code that's checking the controller inputs. So let's take a look and see if this is running and if there's any updates to the scrolling. Now there are. That's weird. So look, there's some sort of long delay before it actually hits that. So there's the breakpoint. We're checking for the input here, which means we're in the gameplay loop. Right. We've got our background loaded. Oh, that's bizarre. Okay. Is it not doing it anymore? I don't understand. What is that delay? didn't. Come on, man. So what is it doing? Branch not equal 84, 85, compare 1. Load A. It's in this loop. It's almost like it's processing the NMI, but the actual game logic hasn't completed yet. And it's waiting. Draw complete. Is it because draw complete is getting set to a value that it's not checking for? Compare 1. Branch if not equal. So if it's not 0. Oh no, if it's not 1. Probably don't want to do that. I probably want to do probably want to check just to see if it's greater than 1. I wonder if that's what's happening, is that we're hitting a if we're hitting the if we're hitting it when it's like 2 and then we're waiting for it to overflow. So what is it? We want to branch if it's positive. I don't remember. This is the problem with taking a week off. You forget some of the stuff here. So let's see. Where are we doing some of our bounding box stuff? So let's see. Add, store, load, store, clear, carry, add, store, transfer, push, load, bullet, store A. This is a flyby, collision point. So branch carry clear means it's greater than or equal to. Well, that's for the add. Oh no, that's for the compare. Otherwise, yeah, I feel like I always have this problem after too much time has passed. If the value in the accumulator is equal or greater, carry will be set. So, all right, so where's that loop again? Draw complete. So we just want to check if carry is set. We don't want to do branch not equal so that we're not sitting here waiting for this to be 1 again. We just, whoops, we just wanted to, okay, debugger. Value of the, oh, if the value of the accumulator is, yeah, greater than or equal to, then it'll be set. So if draw complete is greater than or equal to 1, oh, we have to clear it, I guess, in order for that to be accurate. Welcome back, everybody. What is going on? This should have been a simple change. Branch carry. Oh. It is if you have the right direction. Alright. There we go. So that's all it was. Besides me being an idiot and using carry set instead of carry clear, which is not what we wanted. So, yeah, what was happening was it was comparing against 1 and then just saying, okay, the only time we ever allow this to break out of the loop here where we process the game engine is if the value is 1. But if the NMI loop has processed more than 1 time, it will have a value that's greater than 1. So we wanted to change it to, I guess we don't even need to do that anymore, right? Yeah. So what we want to do is we want to compare it, and then if the carry is clear, that means it's less than 1. If it's greater than 1, we'll fall through, and we will store 0 in draw complete for the next time around. All right, so that was unnecessarily complicated, just because, you know, you just lose it when you're not using it every day. It's really easy to go back. Like the code part, I know what I want it to do, obviously, but the assembly, I forget exactly what we need to do here. So that was the initial little optimization I wanted to make to the loading of the tiles, and that seems like that's pretty quick. We could find out how many cycles it is. And we can look at, I mean, obviously we're still not loading any tiles in real time. But we've got our 1300 and change cycles for the scrolling and the calculation of the game loop while the player sprite is on screen. Probably want to do some bounding to make sure the player sprite doesn't go off screen like that anymore at some point. Can still kill our flybys. Things are still running relatively efficiently as far as you know, what's on screen in terms of bullets and player flybys. Man, I'm not sure what I want to work on next. I know we need to be able to draw the maps that we're, you know, creating these meta tiles for. Now that we know essentially how to load these backgrounds, I can do fun things like have this meta tile set. So it should just be one strip of the other meta tile there. So that's. Now, ideally, you know, we want to be able to draw this in real time while the game is running. Well, yes, we do want to do that, but we want to be able to draw this with the asset tool. What we can start with is loading the meta tile information into a file so that we're not hard coding it in like this. All right. Because let me see, what are we actually generating? So we're generating. Are we doing that metatile char.inc? Yeah, so we're generating this with the tool that's doing the ink bin of the char files for yeah, so that's doing the ink bin of the char files, and we have this filler, which is just an empty set of graphics. And the reason we're doing that is because we want in the PPU, you have the sprites here. We want it on the second bank of graphics, and this is the first bank for the backgrounds. We may decide to change that at some point. I don't know. Just wanted to do that right now so that they're distinct and separated. There are some cool things you can do where you have, you know, your backgrounds be, or like if you have a really big enemy, it could actually be a background, and then you use a sprite to represent the parts that you would hit. So, you know, if you've ever dealt with any of, or seen any of the NES games where you have a lot of, where you have very big enemies that would, in theory, not be displayable because there are too many parts that would be sprites or whatever, you can do a combination of the backgrounds and the sprites to make it look a little bit more, a little bit bigger without having to worry about the limitations of the hardware as much. So I guess what we need to do now is export the bytes for the meta tile, the actual tiles of the meta tiles. So let's do that. Let me think about this. Where? So that's the current background tile. Is that actually used for anything? It's okay, so it is used. Maybe we don't need a whole new section for this. We'll just do a new file. So we'll do a file called meta tile mt tiles. So as we're writing out the actual meta tile char data, we'll be writing out the individual bytes for the meta tiles themselves. Let's call that just metatiles.bin. Trying to think, do we need that to be a separate? I don't think we need that to be a separate include file, because for the entities we do that. Well, but with the entities we have the code that we're generating. All right, so I'm just going to do that as a raw bin file, and then we'll see. We may have to change that. That's okay. Empty tiles. Okay, so now with each of these, we want to write out. Well, the first thing we need to actually do is we need to write out the first set of 0 bytes for metatile 0, which is an empty meta tile. So what did I say? This is a 4x4, so that's 16 bytes. So probably just easier to do. Oh, except we're doing this. Okay, I'll do it this way. Open S like that. Is it like that? What is it? What was that? S open S. Of course, S open S. So this is our empty tiles, and then metatile.bin and O write only and O binary and O create. And then we need to, what is it? sh deny no, and God, I never remember these flags. They're just so obtuse. It's underscore sh deny no and underscore s. I almost have it here. Deny. One of these days I'll remember this, and then si, right? Yeah. All right. So the reason I'm doing that is because I just want to write that as binary. So write, we can do this is kind of lazy, but it's just really easy to do it this way. So we say write empty tiles, empty meta tiles, size of char times 16. Right, instead of doing a loop here. And then, let's see, we can close that here. Let me actually do that earlier. And then what we want to do here is we want to write the individual tile value. So we want to do write empty tiles. So this current item count, we want to write that value plus, well, that's not going to work. Character tile value equals current item count plus current BG tile. Wait, is this doing, this is doing, oh, it's doing all 16 at once. So we're going to do a loop in here. All right, so that's fine. So what we can do is instead of doing the increment of 16 like this, we can do and j is less than 16, j, and then we just write this out. I think that'll work. And then we want to do, well, we'll do current BG tile. It's kind of weird that we have to do this increment like this, but basically what we want to do is we still want to do this increment of 16, but we also want to write out the individual values of the tiles to the file so that we get a map that looks like this, essentially. And we'll look at it in the hex editor to make sure we're getting the right values. Get the screen into the asset tool, finally. So we don't have to start at other than 0. That's just a note to myself so I don't forget to do this. Thinking that'll work. I'm just wondering about the byte ordering here, if that's going to be a problem. I think that should be okay. We'll see. We'll do the export and then we'll look at it in the hex editor. So we just do an export and Fred and have metatiles.bin. So we should have 16 bytes of 0, which we do. And then if we go to this, we should be starting at 59, and we're not. We're starting at 58. That's okay. That's just an off by 1 error. That's fine. And then that all looks good otherwise, other than just being off by 1. All right, so I guess we want to do that instead. All right, so we'll redo that and then re-export it and take a look at it again. And there we go. So those are the values that we want for our metatiles. If we had more metatiles, obviously they would show up there. And now that we've got that exported, we can grab all this content again, drop it into the shooter folder, replace the files, and then change this to be inkbin metatiles.bin. So now we have our metatile data being generated by the tool and loaded up by the assembler. So that should still look exactly the same, and it does. Okay, so that's good. So that means that's working. So now our metatiles are actually loaded from here. Well, I'm rather deliberately avoiding the process of making the asset tool draw the map, just because I'm having a fun time being in the NES code in the assembly, and we're going to end up going back into the asset tool for a while to draw the map. So let's see. The only other thing I can sort of think we could do here is rather than what we're doing here, where we're doing all the initialization in this call, we could make this a separate subroutine that we can call. And we could do something like, let's see, how would we... We could pass... So we need to provide the subroutine. Basically what we would want to do is like something like this, load level, and then the subroutine to load the level could live somewhere up here, I guess. Probably want to put that in a scope, just so that it's got its labels isolated from everything else. And scope. But we need to now tell it where we want it to load the level from, because basically all I did was I just moved the code, right? It didn't really actually change anything other than now, you know, calling it from a subroutine that should produce the same result, and it does. But what I'd like to be able to do is call the subroutine, passing it the address of the level that we want to load, or an index into a level table that has the addresses of the levels, that then loads the content of the meta tiles, at least for the, right now we just have the two screens. Would want to change that. So let me just look at this, because I believe jump subroutine pushes the adjust the stack. So pushes the address -1 of the next operation on the stack before transferring program control to the following address. Subroutines are normally terminated by return subroutine opcode. So yeah, so it's when you do RTS, it's JSR load level, it's pushing the address of this guy onto the stack so that when you come back it knows where to go. So we need to be able to give it the address of level 1. Now, how many places is that used in? It's just used in that place. So what we could do is we could use just a variable called like param1 or something like that, right? In theory, I think that would work. Although, actually, no, it wouldn't, because, well, it would if param1 was a 16-bit, because we could then load in the full address of level 1 into it, because it's an address. We could have a table that takes an index of the levels, or we have a table that that provides a way of indexing the level addresses, and that would be better, because then we don't have to pass 2 bytes. We just pass the byte that is the index in param1, and then the subroutine will read that into a variable that it can use for loading the level. So let's try that. All of this stuff, like I've said a million times at this point, is, we're learning how this works. So this may change, or we may find that this is super inefficient for some reason, or just dumb, or whatever, and we'll fix it. I'm just being silly here with this. What is that, a tab in there? It's weird. How did that? That must be from when I copied it. What are you doing? Sorry, I'm just visually lining these up so it's easier to read. All right, so param1, and then what we would end up doing is we would have essentially something like level table, or we'll just call them maps generically, and how would you do that? So is this like low byte level 1, high byte level 2? What is the shortcut for that? CC65. Documentation. CA65. I should bookmark this. High byte. So we can even do remember seeing this. I'm not sure what's better to do like a map high, map low. See, yeah. So they do this. They have this table lookup of. So let's do that. And then, so they're just doing low bytes. Is it plural like that? I thought it was. Oh. Oh, I see. Because I guess you can have multiple. Oh, okay. So that's cool. So that's a neat little thing that CA65 gives you. So you can have a table of labels and then have your lookup have the lows and highs pre-calculated for you. That's pretty cool. What is bank bytes? Define the byte size of the data by extracting only the bank byte, that is bits 16 through 23 from each expression. This is the equivalent of byte with the prepended. I don't think we need that. I just want the highs and the lows. So we can do, say, maps level 1, right? And then, well, this is high bytes maps, low bytes maps, unexpected trailing garbage character. Oh, you actually have to give it an. So we define the table and then maps. Oh. So we define a map called, so we're defining a map, or a table rather, of the maps, and then there's level 1, and then from here, maps high and maps low, we are essentially building out the low bytes and the high bytes so we can look up the location in memory easily in our load routine. So load level, so we want to load a with 0 store into param1, right? Because level 1 is level 0, we'll do a 0 index to make it easy. And then what we can do is in here, we want to use, let's see, do we have any 2 bytes that we can use for something? We have sprite mem, which we can use beforehand because we shouldn't be doing anything with the sprites anyway when we're loading the level initially. So, well, I may regret this, but we'll see. Just to save the 2 bytes. So what I want to do is I want to load a what did it call? Maps high load X. Let's transfer X to A, push A, load X with param1, and then we're going to load A with that, and then store A into sprite mem, which is now really not sprite mem, but that's okay. And then we want to load X with param1 again, and load maps high, maps low X, and then store that into sprite mem +1, and then we can pull A and transfer A back to X. I don't know that we need to necessarily even do that. Well, yeah, that's probably unnecessary. Let's just save ourselves these instructions and put a little thing here. Modifies X and A. Does it modify Y? I don't think it does. It does not. Alright, and then we want to do this in a sprite mem, which is, again, technically not the sprite mem anymore, but this should hold the address of level 1 from this maps table that we've defined. So again, we made these changes. We shouldn't actually see any difference in terms of what the visual display is. So that means I did it wrong. But it should behave the same way, but now be a little bit more extendable, where if we create a map level 2 and we can do that to compare, it should be able to sorry, I'm thinking about where I'm supposed to store that to hit that breakpoint. It should be able to read that without any issue, instead of what we have right now, where it's fixed at, or where it was fixed at loading level 1 every time. All right, so let's run, and we hit start, and it should hit the breakpoint. Okay. Oh, we're not there yet. Okay. So let's see. So we want to load X with the param 1, which is 0, which is good. Then we want to load. So the question is that the appropriate address is 8671 actually the address of the map? So if we go to the hex editor, 8671 is that is right. So am I just storing it maybe in the wrong order? So we get 86, and then we're storing that in sprite mem, and then we're going to load X again. We actually probably don't even need to do that. We definitely don't need to do that. And then if we go to the memory, X editor. Let's see, let's look at our bytes here. Where did I store that into? I stored 8671 into 2 and 3. Oh, I didn't store the second byte yet. Yep. And then we are loading A. Okay, so now we're actually beginning the routine of initializing everything the way we want. Right? Yep. It does modify Y, although I don't think I actually use it anywhere. So probably don't need to do that, but anyway. Not important right now. So let's see. So it's loading Y with 0, and then it's loading A. So this shouldn't be 0. Load A, tile X. Oh, actually, yes, it should. Okay. The part where we're going to actually start seeing the sprite memory is where we get the load A over here. which has a value of 86 in it currently, but we're not at the point where we should have something that makes sense yet. Oh, I know why. Okay. I know why. We need to do indirect addressing, and shoot, that's supposed to be Y now. So now we do need the Y. Transfer. Should we just switch to Y indexing for that? Transfer A to Y. Does it need the X at all anymore after that? Doesn't look like it. Okay. So make sure that that's built. And debugger. Run. Disable that. Poop. So it didn't load anything. Let's restart this and see what got broken by doing this. Run. Start. All right. So 8671 is okay. So now we are in the process of getting things going. So we've initialized, we load A with the value, we're shifting right, we're storing A. Wait a minute, did I got ahead of myself. Left shift, logical shift right. Okay, right, and then we're putting that into temp. And then we're loading the Y, and we're doing our shift right and then left again, and then we're clearing the carry. We're adding temp. We're transferring A to Y, which will give us 0, and then we're loading. Okay, so the address is actually backwards now, which that's simple enough to fix. It's just that the byte order is wrong. So what we want to do is we want to say load. We want to load it in that order. And if we reload this again, turn off the breakpoint, I think that'll fix it. So run. All right, cool. So now we got our map back again. So that's good. Everything else appears to be working the way we want it to be. So that loaded the tiles initially. We should be able to do something where if I now say, let's do this. I'm going to say level 2. Let's just do same idea, right? Where we let's make. We're going to make a pattern. I want to make all of these be the background color, and then we'll do this and this, and then so I'm just going to make essentially a big box around the two screens with my meta tiles. If I build that, that's good. And then I should be able to do level 2 like that. And that's good too. And then param 1. Let's see, where am I set? So if I change that to load level 2, which is index 1, I build that. I run it. Yes. Okay, cool. So now we've got our name table filled with that boxy layout that I created by hand. So that's cool. So that means that routine is working to load the initial load of the map. Now, obviously, again, we don't have the full backgrounds going. I'm not really prepared to do that tonight. Where am I? I don't know. I mean, what else? What else do we have? Again, I keep coming back to the fact that I really want to just stay in the NES code. So I like that we've got this partitioned out into our level 1 and 2 table, which has the high and low bytes. Fix that problem. I mean, we could fix the collision to be box based for the bullet. I mean, that's easy enough to do because essentially we're just adding another byte, right? So right now it uses the bytes here to say how many points there are. We could change it so that it always assumes there are 4 and then use a standard bounding box for the collision. So something like, I mean, this is a really big bounding box, but so if we change it to be like this, where we say, okay, so there's I'm just manually typing this in. Eventually we would again load this from the metadata that's being generated by the asset tool, because right now the asset tool does actually have, if you click on a sprite, shows a bounding box. You can't control the size of that yet, but it also has to generate that output about the bounding box of the entity. I assume that this is going to make it so that the bullets collide even though they look like they're too far away to collide. Kind of hard to say with it running so quickly. You can slow it down and look at the actual collision and how it happens. I mean, like I said, I'm assuming that this is going to be pretty, yeah. So it's because the bounding box is right fully around the entire outline of the 8x8 sprite. We could tighten that up, right? We could say it's more like 6 and 2, just so it gets in a little bit closer before. And then basically what we would want to do is, like I was saying, all of this is, it's counting, it's using the byte in there to determine how many points it's checking against. It should really be checking just 4 by default because we want to make everything use a bounding box. Yeah, that was a little bit close maybe, but that's much more like what I would expect. So SCAC. Yes, that is NES source code. Sorry if I didn't see your handle there correctly. Yeah, it's 6502 assembly code, and that's how you write an NES game by hand. You can do it in C also, but it's not going to be as efficient as writing the assembler by hand because the compiler, it's going to tend to generate more verbose code than the CPU can actually handle, and you can kind of take some shortcuts if you're doing it by hand. So yeah, I mean, at this point, I'm almost thinking I'm gonna call it a night, even though this is typically shorter than my usual streams. Usually I go for at least 2 hours, but just coming back to it, I'm pretty happy that we've actually made this much progress separating things out and getting ourselves set up for loading individual levels. Yeah, sorry, Angeliki. I know. It's just, I don't know. What else can we... I mean, I can work on the map in the asset tool, but It's just a lot. Buffering video. You want to explain what you're talking about? I'm not sure I follow what you mean by buffering video. With drawing the maps, you know, we've got to actually have scrollable areas, and I'm going to be able to place the meta tiles. Oh, the I wasn't sure if that was a buffering video comment about the NES, or that, yeah, like you said, maybe it's a streaming issue. Twitch is saying that my stream is pretty good, so it might just be a localized issue. I also have to work on the bounding box tool part here. It's just a lot of sort of administrative stuff that's not related to the NES that I know I gotta do. This is where I mean, this is where all sort of game development, I think, for everybody kind of hits a roadblock, right? It's like, it's really initially it's really cool because you know, you're like getting stuff showing up on the screen, and you're messing around with the hardware, and you're kind of learning the ins and outs of the sort of the basic stuff, and that's when the idea is all kind of new and shiny, and then you get to the point where you're like, yeah, I'm actually working on a game. I gotta actually make all of this happen, and it's got to be efficient, and it's got to work, and that's where it becomes just the persistence of actually building your code. I feel like that's where, you know, once you get past the new project feel, it's when people stop working on their games. So let's see if there's any. I mean, there's so much we can work on. One thing that I'm still not really happy with is the movement. I feel like it's still very, still pretty janky. Like, I feel like it's still very, very loose. And I'm not sure if just changing the max velocity is going to fix that. Yeah, see, it looks like the up and down physics are not exactly right. So as far as cool graphics tricks we can implement, I mean, one of the things we definitely will need to do is we're going to need to have some sort of heads-up display with like your score and maybe how many lives you have or what power-ups you have, and that is either going to need sprite 0 hit detection, or we could even use scanline counting so that we can see. I'm just changing this level so that it actually looks like it has a border on it. So, hey, it's like we're almost flying down a corridor like in a real shooter. So yeah, so one of the things we'll have to do is implement, we can try that, we can see, and that's probably going to fail miserably, but we can try implementing sprite 0 hit. So the way that works, or to explain a little bit better, when you're building a game that has sort of discrete parts of your screen, so like in this case I've got my shooter and I've got the fake walls, right, and here's the ship in the middle. If we want to have status stuff down here, there's no such thing as like overlays or anything like that. What you're doing is you're generally, for something like that, you're positioning sprite 0 at the point that you want to split the screen. And then when you find that you've actually hit that part of the screen, you are changing the background to draw your heads-up display or whatever information you want to do there. So we could do that. The other approach you can do, which is different and harder in some sense because it involves more work, is you could also use you could count the scan lines, and then when you get to the right scan line, switch it. If you were using a mapper like MMC3, which gives you an interrupt per scan line, that seems wasteful for this. Typically, if all we're doing is looking for splitting the screen there, then we are gonna just need the sprite 0. If we wanted to do something like something cool where like maybe we want the wall to go wavy instead of just being fixed like that, so like have almost like a sine pattern to it. That's something that you could use MMC3 for, because again, you get an interrupt for each scan line, and so with every scan line, you can change the positioning of the background, and it will shift slightly on the screen, and then you get this sort of wavy pattern as a result of doing that. We could do that too, but I've got to then change the mapper, and that changes some things. I'm not sure what impact just changing the mapper will actually have on the game. Just for fun, be curious to see. The interesting thing about this is that, like I said, all of that handling is happening in the interrupt handler, and the interrupt handler happens here, which is currently set to 0 because we're not doing any interrupts. This was, if you remember, and I think I explained this maybe in the last stream, I don't remember. Right now we're using the NMI and the reset interrupt handler. We're not doing anything for this, but if we switched over to MMC3, then we would need to include that. So I think it's turned on by default. Let's see. So how do we set the mapper? I mean, this is probably going to break the game, but we can try it and see. Just for fun. Let's see. Lower nibble of the mapper number. So that's flag 6. So that's in bits 7654. So let's take a look at the mappers and what number it is. Actually, probably want to just do this. MMC3. So it is mapper -4. So we want to put the value 4 in this. So this is binary. So 1, 2, 4. Oops. Okay. So we've switched the mapper. Yeah, and as expected, it broke the game. My guess is that it's because the graphics, yeah, so the graphics are all messed up. The other thing is we never, let's define that here. We're not going to do anything with this, so let's just add a So it looked like it might have actually potentially worked at first. Like if I slow this down, it did look like it was populating the... Yeah, it was populating it, and then something broke. Darned if I know what. Anyway, we can change the mapper back. What we want to do, let's not mess with that now, because I don't really know enough about mappers to know what actually broke by doing that. But we could do something with the sprite 0 hit. So one of the things though that we'll need to do is in our draw entities right now, it's starting at sprite 0 when it goes into it. So draw entities. So what I want to do is I want to change that to this, right? Because I believe X is actually the index. No, that's the entity index. The sprite mem index is going to be Y. So we want to increment that because we want to save sprite mem 0 for sprite 0 hit. And we'll position it accordingly so that we can do... Oh, the ship disappeared. Load Y. Oh, well, dummy. Yeah, that's not going to work. No, wait, that should have worked. That should have worked. Load Y1. And then for sprites, it should be starting at sprite mem. Oh, no, that isn't going to work because it's not sprite mem 1, it's sprite mem, or yeah, so it's the 4th byte because there are 4 bytes that make up the sprite. Okay, that was just silly. All right. So, okay, cool. So, and that all works the same otherwise. So now what we can do, let's figure out where on the screen we want to place sprite 0. So sprite 0 right now initializing that sprite memory. That's clearing the entities. That's clearing this to that. I will... Okay, so we'll do it right here. We actually don't need this anymore because we're not doing the call to the randomizer. Load A to that and store it in the seed. We don't care about that. Okay. So what I want to do is I want to initialize sprite 0. So we will load A with well, we want to load Y, I guess, with 0. I don't even need to do that. I know the address is 200. So, yeah. So, let me think about that. So, I want to store the Y position. So, load A, and then the position we want on screen, I believe 240 is the maximum Y that's visible. So we'll just do it a little bit higher than that. 240 lines. So let's say we'll just use 40, right? We'll just use 40 lines. So 200 decimal is C8 in hex. And then we'll store A in 200 X. Let's make sure that X is 0. And then load X 4, 3, and load A 0, and store A, and 200 X. So we're initializing the memory for sprite 0 to position it at essentially, if this is line 240 here on the screen, we're gonna at line 200. Well, actually, it's over here at line 200, and so 0, 200, right, where you have sprite 0 positioned there, and we want to now do sprite 0 hit detection. So let's look at how we do that, because I don't know. Sprite 0 hits. Sprite 0 is sprite controlled by it. Yeah. It's controlled by that. The sprite 63 is that. The PP is drawing picture. When an opaque pixel of sprite 0 overlaps with an opaque pixel of the background. Oh, so it has to be when an opaque. So it can't be. Interesting. So it can't be a transparent pixel. So that can be a problem. Mr. NES code. Sprite tile 0. If you look at it, is that guy. I guess we want to make it the flyby, even though we don't really want to see it. Well, let's just see how this works before we do anything. We should be seeing the sprite, unless I didn't assemble it after that change. Let's see. Should be seeing a sprite showing up there. Did I mess this up? So byte 0 should be the Y position. It is. Byte 1 is the tile index, which should just be 0. Byte 2 is the palette. And byte 3 is the X, which is 0. Alright, so what gives? Again, this is one of those things where I like other emulators a little bit better. Let's do that, because I want to be able to see. I want to actually see where the heck it is. Nintaco is pretty good, and it's got a nice facility for seeing where your sprite actually is. So where did that download to? Chrome? Show in folder. Oh, it is on my desktop. I was just impatient. Okay. So it's going to give me a hard time because it's Java. Or is it just not going to run at all? Where's the... Oh, is it running? Oh, it was invisible. All right, so if I open the shooter, assuming that there's nothing wrong where it's not going to work in Intaco because it's got some issue that FCEUX is ignoring. Input settings. No. Where's the mapping? Button mapping. Set all. A. B. Select. Start. Up. Down. Left. Right. Shoulder button. Left shoulder button. That's it. That's fine. Start. Okay. So where is sprite 0? Highlight selected sprite. Okay. So this is cool because this will illustrate some of what I was talking about. So you can see that when I click on the sprite here, it's actually showing. Why is it showing 8x16 mode? I don't know, but is it hidden because the X is 0? If I make the X 1, is that going to fix it? They have a... X is 255, Y is 255. I must be oh, yeah, okay. So let me do this. Let me make this a subroutine. So what's happening is I'm clearing out the sprite memory each time, which probably isn't necessarily important, but I do need to set the sprite position every time. So after I'm done with that, I can call initialize sprite 0 illegal addressing mode. What? Sprite 0. Oh, return subroutine. Yeah. All right. So let's reopen that. The position is still wrong. Grr. Am I not actually calling this? Yeah, that's... draw. Okay. Should be able to just do this. It's kind of a lazy way to do it, I think, but just want to make sure that we actually get the sprite showing up. There it is. Okay, so there's our sprite 0 now. If I click on it, you can see it's selected. Good. So obviously I'm clearing out the memory somewhere. Don't really care where right now. Now, we've got our sprite in the place that I want it to be. I assume that probably what I would want is just a tile with a single pixel in the corner. But I don't care about that right now. Where is NestDev? Oh, okay. I've got that open. So let's see. While PPU is drawing, the PPU detects this condition and sets bit 6 of PPU status to 1, starting at this pixel, letting the CPU know how far along the PPU is in drawing the picture. Sprite 0 hit does not happen if background or sprite rendering is disabled in PPU mask at x equals 0 to x equals 7 if the left side clipping window is enabled. So I believe that is enabled. Because I don't remember deliberately changing that, so we probably need to shift the, we either need to shift the sprite or change that bit at x is 255 at any pixel where the background or sprite pixel is transparent. If sprite 0 hit has already occurred this frame, okay, so that is reasonably logical. I didn't see any big gotchas other than what it was saying about the X. So let's just make this 8, just again for sort of the simplicity of we're learning how this works. I'd rather not deal with changing PPU status to make it work if we don't have to. All right. So now what we want to do is in our NMI code, I guess after we're done with the PPU, what we want to do is we want to look for that bit being set. And it's bit 6 of PPU status, which is 2002. So we would do basically load A 2002. And 0, 1, 2, 3, 4, 5, 6. Wait, this is 8, 7, 6. Yeah. So let's see here if there's anything. Cleared at .1 of pre-render. Okay. So we want to do that and then branch if not equal to, let's see, wait, call this wait sprite 0. Branch if equal to wait sprite 0. So we shouldn't get into an infinite loop by doing this, which is hopefully a true statement. We'll see in a moment. No, it looks like I locked it up. So debug, debugger, pause, step over, yeah. Oh, is it ending the address? Oh, come on, man. I want to end the value, not the value of the address. That's not right. All right, so let's reopen that. Okay, it's still broken, but different. Step over. Now, it's just if the sprite has a transparent, but not the background, right? While the PPU is drawing the picture, when an opaque pixel of the sprite 0 overlaps an opaque pixel. Oh, so they both have to be opaque. trying to think what we would want to do. Hey, real Zachary Lusk. So the problem is we may be in a situation, yeah, we don't want to do this here where we may be in a situation where we don't have anything on the screen. Could do it here where we know we've drawn sprites, because at least at that point it's a pretty good chance that we have something on the screen. Not that we would want to make the game rely on pretty good chances, but just for the purposes of trying this out, we can see if we can get this to work. Okay. So it's locked up. But that's, let's see, step over. So we're basically waiting on, let's see, what else does this offer us in terms of, so there's our sprite. Update on sprite 0 hit. Oh, can you, oh, that would be cool. So is that what that's doing? No. It's showing the selected sprite. All right. So we know the sprite is there. Is there a way to, that's for addresses. I'm trying to figure out is why we're never getting the sprite 0 hit set. Like we've got a sprite, it's got a value. They're not transparent. So it should be just running at this point. Load A 2000. Step over. Can we see what the scan line is currently in the debugger? Could be that this is the wrong place to do it. Like maybe we don't want to do this. Oh, we do have it right here. It's 223. Like maybe we want the maybe we wanted to, oh, you can actually, oh, that's cool. That's really cool. So you can actually step by scan line. So what I'm wondering is if maybe we want to do this check in the game loop and not in the NMI. So let's see. Once we get to the line, scan line 199, we should be getting a value from 2002, unless I'm reading the wrong, am I reading the wrong register like an idiot? Let's see. Bit 6 of 2002, which is what I'm looking at here. Load A 2002. Okay, yeah, so hit. Okay, so we should, at this point, I mean, this should be it. So I keep step over, step over. We can do it the individual dots. That's pretty cool. 0A. just using the wrong bit? I feel like maybe I'm just using the wrong bit. I don't know. Value in hex 20 by bit 1, bit 2, bit 3, bit 4, bit 5, bit 6. So that should be it. So I'm doing a lot bitwise AND on the value. It will branch if equal, which means it's 0, which means the bit isn't set. Is it just not triggering? Oh, wait a minute. You can... Holy crap. So you can... What is this? You can force it to simulate sprite 0? Really? Why isn't it working though? Oh, because it's not at a scan line yet. And it's clearing it out. No. What is that actually doing? Or is it... Oh, maybe it's showing me when sprite 0 is actually hit. Step to next NMI. That's super helpful. Oh, step to next sprite 0 hit. It is set. Okay. So it's 4A. I just have the wrong... I'm checking the wrong bit. That's all it is. It should be 4 instead of 2. Wow, that was super helpful. Where's my code here? So it should be that. And I may switch to this permanently. I've mentioned that in a couple of streams, but... Okay, cool. So now we're not stuck in an infinite loop because sprite 0 is actually happening, but we weren't detecting it properly. Nice. Okay. So now, well, now, I don't know. So now we gotta change the background. Like, what do you do? That's a good question. So I'm going to cheat and see what the Nerdy Knights say on what you do here. I don't know if I'm gonna find out anything different than what I thought, but I assumed that it was just you're gonna... Well, you know what we can do that would be kind of fun to mess around with, just to show the way that it works, is that we could mess with the scroll X. So like if we load a 0 and then, well, we've got to load a 00, store a 2006, then load a 0, store a 2005. We've changed the X scroll at this point after we hit sprite 0. So what we should see is that like the X, oh, well, I want the X scroll to be something different than what it is right now. So let's change it to like 50. That's too big. 10. So we should see that now the background will be all skewed. If I'm if I'm using this or misusing it correctly. No. I guess we still need to load the scroll Y properly, or it's going to break things. All right. Let's see if that... so the whole thing is skewed now. So that didn't work the way that I expected it to. So the X value isn't changing only on the X value isn't changing only on the sprite 0 hit. Do I need this? Oh. No, that's for, okay, that's for the, let me take a look at this because I'm not remembering how that works exactly. Now we're just getting into me breaking things for fun, but hopefully we'll get a cool effect out of it. So let's see, 2005 is scroll. Okay, so that is not the way to do that. You want to read that and then store. So we want to load a 2002 and then, which we're technically doing anyway. Why is it using bit versus, I guess maybe it's faster? I don't know. Let's just use what they say. So let's see if this unbreaks my broken code. Interesting, but not doing what I wanted it to do. Like, well, I mean, it sort of maybe is. It looks like it's adding some sort of squiggle here. It's like if I make this bigger, I feel like it's not really going to have much of an impact. Yeah, it's just shifting everything. So I guess that probably what I need to do is I need to read up a little bit more on how this works, but well, look at that. That's what we're doing. When the loop finishes, the PPU is drawing the first pixels of sprite 0 that overlap with the background. We add a small wait loop so the rest of the status bar is drawn, and then change the scroll registers. The rest of the screen is down. The screen down is drawn using those settings. So to avoid being tripped up, the flag is cleared at the end of the V blank, so once it equals 0, you know the next frame is started. I assume that what we're going to need to do now is So yeah, you can see that what's going on with Super Mario Brothers is there's a sprite on top of the coin, and that's how the status bar works there. It's drawing the text. Now it's doing it at the top. Of the screen, and I assume that it's because that's an easier way to do it. Like what we would need to do essentially is once we got to yeah, I need to read up a little bit on this because I'm not sure. I feel like I probably am missing something critical to there. I mean, it's cool we got it to recognize that sprite 0 is being hit. It would have been neat to do something a little wacky versus just shifting this. Back to normal here. Surprised changing the scroll didn't actually do anything. Wonder if it's because there's something with the way we're doing this. Load A0, clear 2006. Let's see, 2006 is the memory address, isn't it? Yeah, it's the address that it's referencing. So we're clearing out that register, and then for the Y, we are probably want to do this here so that that's actually being done correctly. Not that I think it's going to actually change anything about the way that it works, but yeah, I got to research a little bit on what we can do to use the sprite 0 properly. Just because I don't really know how. I don't know what the expectation is in terms of like how your background is going to change and if that's going to affect the way we're loading levels. I mean, it's a good time for us to be doing this, I guess, because we are effectively dealing with the level stuff now anyway, but I really have no idea how this works, obviously. I mean, we're not even seeing this shifting back and forth. So I'm thinking that like we should be seeing, I think what I wanted to be doing is shifting the X back and forth, but I suspect that it's not going to do that because I'm just not understanding how the scroll registers work properly. Like it's probably like I'm not sure how we would even do that. I mean, what we could do is on sprite 0 hit, we could load an address with a tile, but that doesn't really help us. Yeah, I gotta read into this because I'm obviously not understanding exactly how you use this to do the status bar, but hey, you know, we're detecting that it's actually occurring and it's not locking up anymore, so that's good. And we made some progress where I thought I fixed that. Made some progress where we can load levels, different levels. We have our scrolling working. We've got to add now that we can actually change the backgrounds. Yeah, I mean, it's not really broken, I guess. It's just that it's not. It's obviously not doing exactly what I want it to do. But I'll do some research about how that's supposed to work, and I will come Thursday a little bit more prepared than I am after being off, and hopefully we'll have some more map stuff working, and yeah, half implemented exactly. And we'll continue on from there. But you know, making good progress. Things are coming along. We may end up having to rebuild some of that level editing stuff. Level loading stuff because of the way that the sprite 0 hit stuff works. But I'll read into that. Yeah. So any questions before I wrap it up tonight? All right. Yeah, I'm looking forward to Thursday too, and I think it's going to be a good one. So thanks for watching. I'll see you Thursday.